Hello, this is Mr. Collier, and today we're looking at testing the validity of arguments using truth tables. So an argument is made out of one or more premises, things that are taken to be true, that lead to a conclusion. A compound statement that includes an implication is called an argument. An argument is usually indicated by the words therefore and hence. The premises and the conclusion are propositions. If the premises provide support for the conclusion, then the argument is considered valid. So basically what's happening here is we're going to have a compound statement, and if it represents a tautology, then it is valid. So basically you're going to do a truth table. If you get a tautology, then it is valid. The argument is valid. If it's not a tautology, then the argument is invalid. So for example, prove if Fuzzy is a bear, then Fuzzy is a mammal. So we're given that, if Fuzzy is a bear, Fuzzy is a mammal. Fuzzy is a bear, therefore Fuzzy is a mammal. So basically, in these arguments, what you're going to have is you're going to have a bunch of premises, things that we're going to take to be true, make a truth table, and then we have a conclusion. Okay, if when you get to the conclusion, then it's a tautology, then it's a valid argument. Alright, so we have the two statements P and Q. Fuzzy is a bear, Fuzzy is a mammal. The conclusion is right here, look, Fuzzy is a mammal. So that's the Q right there. The conclusion is Fuzzy is a mammal. And we're going to see if that is a valid argument or an invalid argument using a truth table in a second. So here we have the two different premises. Two different basically statements that we have. If Fuzzy is a bear, then Fuzzy is a mammal. That's P implies Q. And we have Fuzzy is a bear. That's Q, right? So we put those two together. We can say we put those two premises together using an and symbol here, and then we have the premises are all together here. So this is all the premises. This is what's saying if Fuzzy is a bear, then it's a mammal, and we're also given that Fuzzy is a bear. So that's all your premises, and then we have, so here's your premises, as we just saw, and this is your conclusion. Okay, so an argument looks like this. You have a bunch of premises, and then implies, and then a conclusion. So we're going to work out the truth table for that, and then if we get all T's here, if we get a tautology, then it's a valid argument. If even if one of those things is false, then it's going to be an invalid argument because it's not a tautology. Right, the hardest thing is setting this up, maybe. Once we have that done, then we just need to do the truth table, right? So P implies Q is only false if P is true and Q is false. The rest of them are true. Then we have P implies Q and P. That's only true if these two are true. We're looking at these two now. P implies Q and P is true here. And the rest of them are false. Okay, so now the final one here, we have this entire statement P implies Q and Q is this column. Q is this column. Okay, so remember this is an implication, so we're looking for true false. True false. So here we have only one true, and over here that is actually true, right? So it's true, true, so that's not false. None of these statements are going to be false. They're all going to be true. Okay, so remember the implication is only false if we have the first statement is true and the second one's false. We don't have that in any cases here, right? So here we only have one true, and then there's true over here. So that means that everything is true here. So we have a tautology. So you can say since, actually we can say that right here. Since we have a tautology, tautology, it is a valid argument. Alright, so let's take a look at another example. Okay, we have an argument here. If Katie plugs in a DVD player, so I guess that's going to be our P. Katie plugs in DVD player, then it will blow a fuse. So I guess Q is going to be it will blow a fuse. Okay, and then we also have the statement here, she does not plug in the DVD player. Well, we're going to get to that in a second. Now we're going to look at not Q. P and not Q is obviously Katie, sorry, does not or doesn't plug in the DVD player. And not Q is it does not blow a fuse. Okay, so we're going to assign symbols to the argument here. We have P, then Q, right? Here she does not plug in the DVD player. That's not P. And therefore, so that's going to be come up to our conclusion. It will not blow a fuse is not Q. Okay, so we take these two statements, we stick an and in between. Oh, I always do that with the and. Hang on. We stick an and in between and then implies not Q. So that's our whole statement is going to be P implies Q. Okay, if Katie plugs in a DVD player, then it will blow a fuse. And then we have not, she doesn't plug in a DVD player. Therefore, it's not going to blow a fuse. So this is our argument. We're going to try to figure out the truth table for this. If it's all T's, if it's tautology, then it's a valid argument. So let's work out, I see we need a not P and a not Q, and then we'll figure out the rest of it. Let's just do not P and not Q first. Okay, so not P is false, false, true, true. Not Q is false, true, false, true. Let's do P implies Q. P implies Q is only false if we have TF, and it's here. The rest are okay. And then we need to do, I guess, P implies Q and not P. Again, I made a little A for that and symbol. Oops. Okay, P implies Q and not P. So we're looking at right here, P implies Q, and then not P over here. So we're going to look at these two. And is only true if both of them are true. So the last two here are true. That means the others are false. Alright, so then let's look at the last column here. Then we're going to have P implies Q and not P. All that implies not Q. Okay, so it's implication. This is only false if this first thing, so let's look at what we're looking at here. This is the first thing here, so that's got to be true, and this one's got to be false for the whole statement to be false. So looking at these two, looking for TF. So here we have a TF. Okay, so this is true and this is false right here. So that means the statement is false right here. The rest of them are true. It's not a tautology. Since it's not a tautology, it's not a valid argument. Oops. Okay. Next, alright, so if we're going to have three statements here. If I kiss a frog, so I guess P will be, I kiss a frog. It will turn into, so that's going to be implies, it will turn into a handsome prince. It's going to be Q. It turns into prince. If that frog turns into a handsome prince, I will marry him. Okay, we have a new thing here. I will marry him. I will marry him. Alright, so if a frog turns into a handsome prince, remember that's Q, right? Then I will marry him. We have R here. Therefore, okay, that's going to be our, this is going to be our last part right here. Therefore, if I kiss that frog, I will marry him. If I kiss the frog is P, I will marry him is R. Okay, so we're going to have this giant statement right here. We're going to have P implies Q, and Q implies R, implies P implies R. Okay, so we have the truth table here for P, Q, and R, and we have 8 different possibilities. We're going to have to work out 1, 2, 3 things, and then figure out the entire thing, I guess. Okay, let's try it out. Let's do P implies Q first. That's only false if we have P is true and Q is false. Let's look for that one. And that's, oh, there's 2 of them here. Okay, and the rest we have trues. Alright, then we have Q implies R. So we're looking at TF with the Q and the R here. So we have a false there. And we have another one down here. Okay, then the rest of them are going to be true. Alright, so let's join those together now. We'll have P implies Q and Q implies R. Alright, so look at these two. It's only true if both of them are true. So we've got true there, and we've got 2 more trues on the bottom. And the rest are falses. And then let's do P implies Q, sorry, P implies R. So we're looking at P and R, and its implications, so it's only false when we have true false. So this one's false, true, false, true, false. So this one's false, and that's it. The rest of them are true. So the last statement is this one. P implies Q and Q implies R implies P implies R. So to work that one out, we're just looking at, well, as we're looking at these 2 columns right here. If we have true, false, then we have a false. So let's look for true, false. There are no true falses, so there's no falses in here. There's going to be all trues. Okay, that's a tautology. Since we have a tautology, it is a valid argument.